So in this session, I will brief about the traditional as well as non-traditional machining process, and mainly we will focus on non-traditional machining process. I hope you all of have received the required PPT and the PDF files on LMS. So I insist all of you to go through all the PPTs which I have uploaded on LMS, right? And as far as the examination is concerned, let us wait for the further notice from the university. So in this sessions, I will brief about the non-traditional. So let me share a window. Okay, so can you see this image? So if you see this image, see, we will be focusing on unit number 3 and unit number 4, right? As we know that we have 4 units in this syllabus of advanced manufacturing process 2. So the first 2 units talk about conventional machining or traditional machining, and unit number 3 and 4, they are all about non-traditional or unconventional machining techniques. So for the sake of simplicity, we can divide these non-traditional machining techniques or methods in these 3 categories. So these 3 categories are nothing but the based on energy source they use for cutting or machining. In conventional, we use different types of cutting tools, right? So the cutting tools make contact with the workpiece, and because of the relative motions between workpiece and cutting tool, the friction is developed, and so on, the material is removed. Unlike the conventional machining, here we don't use any cutting tool, but we use a different form of energy that can be utilized to cut or machine the metal. So mechanical source of energy in terms of mechanical energy, in terms of ultrasonic waves, right? In terms of high velocity fluid in waterjet. So that is a mechanical. And for this mechanical energy, I have uploaded self-recorded video of non-traditional overview and the second video of ultrasonic machining on the YouTube. So kindly go through the respective links on your LMS. The second category is a thermal. So here, basically we use a heat to remove the metal, maybe layer by layer or maybe in bulk. So for that, we have these categories, right? EDM, electro discharge machining, that we do have in our workshop. And most of you have hands-on experience on this machine. So we can use the conductive material, right, as a cutting tool in form of wire, if it is a wire cut. Then electron beam machining. So here, the beam of electron can be used to cut the material. So here the electron beam will possess a very high amount of thermal energy. So basically you can have the melting or partial melting of the workpiece, and so on. You can reduce the dimensions and you can have the machine component. Same thing, having a laser, ion beam and plasma beam. So all these PPTs I have uploaded under the unit number 4. If you go to your LMS, I have uploaded the respective PPTs on a unit number 4 on LMS. And the third category is a chemical or combination of electrical and chemical, that is electrochemical. So mainly you can focus only on electrochemical machining. So this category, only one category, you can restrict yourself that how electrochemical machining can be used. So now I will go back to the main file and I will summarize the non-traditional in very good picture form, and then we will discuss further. So now can you see this picture? Nitesh, can you see? Okay. So here you can see this is a main family of non-traditional machining. If you see at the left hand side top corner, that is ultrasonic machining, right? Then laser beam, water jet, abrasive jet, electrochemical, EDM, electro discharge or electrical discharge, and EBM, electro beam machining. Now, what we need to do, because we are doing MTech in manufacturing. So what is our role? So in all these different types of techniques under non-traditional machining, you need to keep in mind three aspects. So there are three aspects, right? The first aspect is to understand the basic working principle of each of these processes. Second, the setup or the basic components of a machine. Third, the process parameters of each process that govern the quality of the machining. Again, I am repeating, for all these non-traditional machining processes, we need to develop the fundamentals of three aspects. The first one is the basic working principle, how it works. Second thing, the components, the machine components that used to take part in machining. The third one is the process parameters. The process parameters, just like in case of conventional machining, we used to always talk in terms of speed, feed, and depth of cut. So what about the machining parameters in non-traditional? So here in non-traditional, the machining parameters vary from process to process. In ultrasonic, it may be different process parameters. In laser beam, it may be different process parameters, and so on. So for that, you should be able to identify the process parameters of each process and how they can influence on the quality of the machining. So quality of the machining means that obviously the first will be the surface roughness, right? The second thing would be MRR. And the third thing would be the dimensional tolerance as well as dimensional accuracy you can achieve. Okay. Again, I am repeating, the machining quality means the surface finish or a surface roughness. Second thing would be MRR, at what speed, at what rate they can remove the material. And the third machining quality would be interested. Can you listen me?
Yes, sir.
Okay. One person, yeah, one person, one or two persons can make their audio on, no problem. So if you have any trouble, then you can stop me.
Okay.
Okay. So
Okay, sir.
So surface finish, right? Then second would be MRR, and third would be the dimensional tolerance as well as accuracy. So the third aspect, what I have told you, the dimensional accuracy and tolerance, and that is very much important in micro and nano manufacturing. Now, the technology has advanced, right? So the new era of machining has already arrived, and you will see a lot of opportunities in future in micro and nano manufacturing. So in micro and nano, you will see the dimensional accuracy and tolerance play a huge role. You may have tolerance in nanometer, and that is only possible by non-traditional. Okay, so let us recap these processes. So ultrasonic machining, as you can see in the schematic, just try to observe the schematic. Okay, the schematic is beautifully picturized. You can see that how the material is removed. Here you can see that this is a workpiece and this is a tool. Now the tool is nothing but a tool is connected to the source of mechanical energy in form of ultrasonic transducer. So here what you can have, this is a transducer and this is a tool. A tool is made of hard material, right? Maybe steel, maybe tool steel, sometime maybe copper, and so on. And the mechanical energy, you can say that it is given to this transducer, this ultrasonic transducer, and you can see that the frequency of more than 20 kilohertz basically is applied, and it gives reciprocating motions. You can see that this up and down translatory motion in this fashion. So this probe will be moving up and down, maybe few thousands in every second. So you see the type of motion is a high frequency. So it will be translating very fast that we cannot observe from the naked eyes, right? So what will happen? You can see here, this tool, which is not in contact with the workpiece. So here there is no direct contact. You can see that between the workpiece and this high frequency translatory motion tool, there is no physical contact. Very minor gap is there. Just like in case of arc welding, right? When we do arc welding, we always maintain certain amount of gap between the electrode and workpiece, right? Same thing here. You can see there's a gap, and this gap is filled with this slurry. And this slurry contains hard particles. The hard particles you can decide based on your workpiece material. Okay, if your workpiece material is hard, you can use a slurry of some carbides. If your workpiece material is ductile, then you can go with the lower quality hardness abrasive particles in slurry, maybe aluminum oxide or maybe aluminum powder. So on, you can use this powder slurry, and what will happen? High frequency, high translatory motion, what will happen? The workpiece surface will get eroded, right? So here the erosion of the workpiece surface will take place because of this slurry, right? And the erosion will allow to reduce the dimensions of the contact area, and so on. You will have the machined surface. When we say machining, the machining basically, it's not always to cut the material, right? The machining basically, in mechanical language, we say that we want to reduce the dimension. So when there is a reduction in the dimensions, we call it as a machining or a cutting. So here you can reduce the dimensions, or you can cut, or you can machine by this fashion. And that's why it is called ultrasonic machining. Now the advantage, now always you can compare this process. Okay, as a mechanical engineer, we must know in which category or in which cases we should go for particular process. So ultrasonic machining is best suitable when we talk about the variety of the materials, whether it's a metallic, non-metallic, doesn't matter. Here in EDM, you have seen the EDM, right? In workshop, The EDM, the disadvantage is what? The workpiece must be conductive. If your workpiece is non-conductive, then you cannot go with EDM. So this bottleneck of EDM can be avoided by using this ultrasonic machining. So the ultrasonic machining gives a wide range of material to be cut. But the disadvantage is what? That here the MRR is very slow, and basically it can machine or it can cut the material having the size limitation, which is directly proportional to the area of your tool or probe or a sonotrode. So whatever the area of the probe which is in contact with the workpiece, that can do machining at particular that time. So that is the limitation. So it may require more time for the larger area of machining. Similarly, in case of laser beam machining, right? In laser beam machining, same concept of laser welding. In the previous semester, we learned about the laser beam welding. Am I right or wrong?
Yes, sir.
Right?
Yes.
So, yes.
Yes, sir.
So same fundamental, that the production of the laser beam and how we can utilize to cut the material. So the same fundamental of laser beam welding that can be used for laser beam machining, but the only purpose is that the output is different. In case of welding, we use laser to join. In case of machining, we use laser to cut. So you can have the dedicated laser source, right? And type of laser source you can use depends on a type of material you want to cut. This is your workpiece. Let us say this is your workpiece. You can use a type of laser, right? And you can set the respective parameters of the power supply, at what energy you excite, and then at what energy, at what intensity of beam you are producing. And the laser beam machining also, then after you have to move this laser source. So this laser source you can adjust on your CNC machine. So that can take care of X, Y, Z, whatever the dimensions you want to control. So instead of your cutting tool, you can put a laser source and you can have the CNC laser beam machining. So laser beam, basically it is known as a versatile technique for machining. But if I want to compare this laser beam machining with the other techniques, right? I would say here, there will be a phase change happens. This is your workpiece. You want to cut or you want to machine. You're applying a thermal energy, right? Because this laser beam machining is basically a thermal source. So what happens? There is a lot of thermal distortion. Again, I am repeating, there is a lot of thermal distortion happens on a workpiece. And as we know that when we apply heat and subsequently when we change the phase of the material, then there is a lot of thermal stresses developed in your workpiece or in your component. So whatever the component I am machining, after machining, your component may have huge amount of residual stresses. And that residual stresses may not be able to deliver the fatigue property or the creep property under the application. So if I'm looking for a fatigue as a main property in my component, then I have to think whether I have to go with the laser beam or not. Otherwise, the laser beam machining is recommended by all the industries. If you see all European machining industries, I think they have replaced all conventional CNC machines with laser beam CNC machining, because laser can do everything. You can make a print, you can make embossing, you can cut anything, you can cut. And the reason the European industries have incorporated LBM, this LBM, because of the productivity. The volume production is terrific. If I compare with all this process, the productivity is very high in case of laser beam. And you know that industry look for always productivity. Yes, Darshan, you please keep your questions with you. We are having second session, right? And we will discuss all the questions, because second session I have only kept for the discussion. I am not going to teach you anything, but it is only for the discussion. Okay. So in next section, we will discuss. Then another mechanical source energy is water jet. You can see the water jet. I think most of you have, I think water jet, I have covered the Zoom session first, right? So I'm not going to discuss that too much in detail, but you see the jet of water, high velocity jet, you can have the mechanism by providing a nozzle, and the nozzle comprises of the fluid in terms of water at high pressure. So you need a pump, right? Or intensifier. And this pump delivers high pressure water. And then after, by having a valve, you can drop the pressure and you can supply it to the nozzle. And you know that the function of nozzle, it will deliver based on the size, the cross section, right? Based on the cross section of the nozzle, you can have a jet of water. And also, in case of abrasive jet machining, you can mix this jet of water with some abrasive particles. Now, the only problem of water jet, that the water jet mainly is suitable for profile cutting or profile machining. Let us take an example. I have 5mm thick plate. And if I want to cut, if I want to make a pocket up to the depth of 2mm, then it is quite difficult, or I would say impossible, to make a pocket by using a water jet, because this jet, let us say this is a 5mm thick plate. So this jet is difficult to control as far as the thickness of the workpiece is concerned. So it will cut throughout. That's why I said it is best for the profile cutting or sectioning. But the advantage is that it's a completely cold cutting. It's a cold cutting. There is no temperature rise, almost no temperature rise. So what happens, whatever the base material properties are there, that will be retained after machining. There will not be any microstructure change because of cold cutting. So you will retain the mechanical properties. So there is the advantage. So for some material, some applications, you want that whatever the manufacturing process you are going to conduct, you want to make sure there should not be any heat generation, not even a 10% degree, 10 degrees Celsius temperature rise, then in that case, this is the best method. In laser beam, a lot of temperature, you see, is a thermal source, a lot of heat. Ultrasonic machining, very minimum heat generation, because this slurry will obviously create a friction on a workpiece, but the temperature is very minimum. Here, there is no temperature. So I would recommend that water jet I will consider as a cold machining, right? So this is the 3 non-traditional machining techniques I just briefed, right? And I would suggest you should go to the LMS PPTs and kindly make sure you should develop the understanding of three aspects. One is working principle. Second thing is the components. Components means in water jet, the pump is a main component, is the heart of this entire machine. Most of the cost, 60% or 70% of the cost is because of the pump. It's very high end pump. Right? Here in laser beam machining, source of laser, very costly, right? So this is the main component. In ultrasonic machining, the main component is what? This tool made of metallic material, right? So on. Now I think this sessions will end in couple of minutes. But meanwhile, you can ask the questions before this session ends. And then we will jump to the next session. Yes, Darshan, you can ask.
Yes, sir. What kind of materials we can machine with laser beam machining?
Laser beam machining you can melt, no problem, not an issue. It's a versatile process, right? So in laser beam machining, what you see, this is a thermal.
Yes.
So as far as material is concerned, there is no restriction.
Okay, but sir, in laser there is one problem of absorptivity. So, is there any difficulty in machining of copper and aluminum?
Obviously, yes. So again, see in copper, as you have mentioned, right? Copper, aluminum. So
Yes.
absorptivity means what? Okay, laser works on which principle? Okay, let us take
Absorption, reflection.
let us take an example. The laser what we use for what I can say marking, right? On a
Yes.
wall, we used to have some 50 rupees laser, right? So in 50
Yes. Yes.
rupees 50 rupees laser, that is more about reflectivity, right?
Yes.
So that reflects. So as you have mentioned that, okay, in some of the material there is an issue of the absorptivity, but as per my knowledge, now there are some commercial lasers are available which can take care of this absorptivity. So it depends type of
Okay.
laser you use. But yes, the absorptivity is an issue. So if you're wearing a material, right, especially pure material, which is not an
Okay.
alloy, so in
Mm-hmm.
that case, absorptivity may play a vital role. Again, Darshan, I would say it depends at what depth you want to cut the material.
Okay.
Uh,
Yes, we can do cello cutting with the help of laser
yes,
to
it
high
depends. If you
absorptivity.
want, yeah, if let us say your plate is 5 millimeter thick, and if you want to have a depth of cut of 4 millimeter, then I would say it will be a little bit impossible or difficult. But if you want to machine per 0.2 or 0.3 millimeter, then it won't be.
Then there is no issue. Sure, sure.
So I think laser beam machining is very interesting, and I would suggest all 15 members that you should go on different materials, okay, which is available online. PPT I have mentioned, but that also you should search that how laser beam machining is evolving. Okay, anyone else? Chintan?
No, sir. No.
Sir, I have one question, sir.
Okay, who is he?
Nitesh.
Yes, Nitesh.
Sir, for example, sir, in a company, sir, there is one 5 mm metallic plate of aluminum or either steel, sir. So in my company, there is 3 machines: ultrasonic, laser, and water jet. So if my boss will ask that which cutting machine can you use here, ultrasonic, laser, or water? So on what basis I will decide that whether I have to use ultrasonic or laser or water?
See, Nitesh, water I have mentioned. Can you control the jet of the water, which is coming very fast?
Uh, uh, no, sir. But
So,
yes, sir. But there is some. So their ball might be there, sir, pressure ball, so we can control.
no. Can you control the jet? Let us say when jet is coming out, you can see this schematic right on screen.
Yes, sir.
So how can I control this jet? So basically you may not have the constant depth of cut throughout the length you are machining, right?
Yes, sir. Yes, sir.
So water jet, I have said it is best for through cut. You can see, because it's a very high velocity jet. Try to understand. If I put my finger, in between jet, my finger will have a drill in a fraction of second.
Yes, sir.
Do you understand what I mean? I
Yes,
think
sir. Yes, sir.
the jet is coming more than sound speed.
Okay, sir.
It's
So
equal
then
to
on
sound.
what basis? So on
Now
what basis
ultrasonic.
I will decide?
Yeah. Now you have two options: laser or ultrasonic, right?
Yes, sir.
The ultrasonic, I have told you that the MRR is very low, because whatever the tool you have, the same, only that amount of region you will be able to machine at a time. So MRR is very slow. And also you have to maintain the slurry, right? So if you have the proper setup, and if you are ready that, okay, you want to, because the slurry you have to circulate constantly. So that is nothing but that will make the process little bit tedious. And if you want to make it automatic, then you can either buy a particular source of laser, and you can just install on your automatic axis machine, let us say CNC machine XYZ, and you can cut. But yes, the laser beam machining will be costly. It would have more cost.
Yes, sir.
Yes, Tejas, I have recorded this lecture and I am going to upload. Okay, don't worry. So I have recorded this lecture, and also you can recap. See, now we are doing master, right? So always think in manufacturing three aspects: the process parameters, how we can improve the quality of respective process. Okay. Meet, any question?
No, sir. Thank you.
And I think Harsh is there today, right?
Yes, sir. Yes, sir.
Last time वो नहीं थे, आज है. And I hope all of you are doing well in health. सबकी health अच्छी है ना भाई?
Yes, sir. Yes, sir. आपकी
Yes,
कैसी है,
sir.
sir?
Yes, sir.
Yes, I am doing great. And please take care of yourself, okay? And also do not compromise with the quality of your study. तो अभी हम
Yes,
क्या
Okay, okay,
अभी
sir.
अभी सेकंड सेशन मैंने क्यों रखा है? सेकंड सेशन में मुझे आपसे डिस्कस करना है about internal assessment, right?
Yes,
So
sir.
I am going to finish your internal assessment by next week. So for that I am going to assign one task. तो नेक्स्ट सेशन में हम
Okay.
डिस्कस करेंगे और आपको नेक्स्ट वीक तक उसको सबमिट करना है ऑनलाइन.
Okay.
And then we will wait for the further notice how the end semester examination is going to conduct.
Okay.
But we will be meeting for further discussions every week. Okay.
Okay, sir.
Yes, sir.
Okay.
And try to think in depth now for a particular process. Okay. For some students, you may like or may not like all the process, but if you find any interest on any one of these process, and try to go in depth. And
Yes, sir.
try to develop the expertise of the process which is in your zone, right?
Yes, sir.
So we will have a break for 10 minutes, sorry, and then we will meet again. And in that, I will discuss about internal assessment. And next week, we will discuss about the other processes, okay?
Okay, sir.
So internal assessment, we can finish. And also it will be helpful to you because it will be a different form of internal assessment. I am not going to conduct any quiz. So let us meet in the next
Okay.
session. Okay?
Okay, okay, sir. Okay,
After
okay,
10
sure, sir.
minutes, after 10 minutes, just click on the second link in the mail.
Okay, 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 sir. Okay.
Okay.
Thank you, sir.